You know, optimizing the CI/CD pipeline is all about streamlining those stages to reduce build times and improve feedback loops. Have you noticed how much time we spend on unit tests alone?
Yeah, it seems like a lot of our build hangs up there.
Exactly. So one approach is to parallelize the test runs. Distribute them across multiple agents. That way, they can run concurrently instead of sequentially. Also, have you seen how Docker images can help with consistency across environments? It's like planting seeds in controlled conditions.
I guess that makes sense. But doesn't spinning up multiple containers add overhead?
True, but the trade-off is usually worth it because you get faster feedback cycles and fewer environment-related bugs. Another thing to consider is catching. If parts of your dependencies don't change frequently, catching them can drastically cut down on download times. It's like reusing good compost rather than starting from scratch every time.
Could be useful, especially for large projects.
Absolutely. And then there's the idea of using incremental builds, only rebuilding what has changed since the last commit. It's akin to only watering the plants that need it rather than the whole garden at once. This saves a lot of unnecessary steps and speeds up the process significantly.
Incremental sounds like a good idea, though it might complicate things when changes are interdependent.
That's why having clear dependency management is crucial. You want to make sure each part knows exactly what it needs without stepping on anyone else's toes. Think of it as everyone knowing where their plant bed starts and ends in the garden. So, what do you think about implementing these strategies? Speaking of speeding things up, automating testing is another key area. We should aim to automate as many tests as possible to reduce manual intervention and ensure consistency.
I agree, but how do we decide which tests to automate?
Well, start with the repetitive ones: unit tests, integration tests. They're the easiest to script and run automatically. Plus, they catch a lot of issues early on. It's like having a robot that checks the soil quality before you even plant anything.
That makes sense. What about end-to-end tests? Those can be more complex.
Indeed, end-to-end tests can be trickier due to their complexity and the external systems involved. But there are tools like Selenium or Cypress that can help simulate user interactions automatically. The goal is to minimize flakiness by ensuring stable environments and clear test cases.
Tools like Selenium sound powerful, but also cumbersome to set up.
They can be initially, but once they're in place, they save a ton of time in the long run. Plus, you can use continuous integration servers like Jenkins or GitLab CI to trigger these tests automatically whenever code changes. It's like setting up an irrigation system that waters your garden based on sensors rather than doing it manually every day.
Automated irrigation does sound efficient.
Exactly. And don't forget about test data management. Using dynamic data generation techniques ensures your automated tests cover various scenarios without manual setup hassle. It's similar to rotating crops. Different data sets keep your testing robust and prevent blind spots.
Rotating crops for testing data sounds like a smart strategy.
Definitely. And let's not overlook the importance of reporting and analysis from these automated tests. Quick access to detailed results helps us identify patterns and areas needing improvement much faster than sifting through logs manually. It's akin to using a garden app that tracks growth and alerts you when something isn't right.
An app for tracking would indeed streamline everything.
Absolutely. It keeps everyone informed and responsive. Now, have you looked into any specific tools for automating our current pipeline? Speaking of speeding up the build process, parallel job execution is another game changer. By running jobs in parallel, we can significantly cut down on overall build times.
That sounds promising. How do you go about setting that up?
Well, first you need to identify which tasks can be run concurrently without causing conflicts. For example, compiling different modules or running independent unit tests can often be done in parallel. It's like planting different types of seeds at the same time in separate plots.
I see. But wouldn't there be challenges with resource allocation?
Yes, definitely. You have to ensure that your CI server has enough resources to handle multiple concurrent processes. Tools like Jenkins allow you to configure executors per node, so you can scale based on available hardware. It's like making sure you have enough water pressure to irrigate several beds simultaneously.
Scaling resources sounds important.
Absolutely. And don't forget about distributed builds. Services like Circleci or Travis Chi support distributing builds across multiple machines, which can further speed things up. Essentially, it's breaking down the garden into smaller sections and assigning each section to a different worker.
Breaking down the work among different workers could really help.
Exactly. Plus, managing dependencies becomes crucial here. If some jobs depend on others completing first, you need a clear workflow definition to ensure proper sequencing while still maximizing parallelism. It's like knowing which plants should grow next to each other and which shouldn't.
Clear workflow definitions are definitely needed.
Agreed. And then there's load balancing, making sure no single machine gets overloaded while others sit idle. This requires monitoring and adjusting as needed. It's similar to rotating tools and equipment among gardeners, so nobody gets stuck doing all the heavy lifting.
Load balancing would help distribute the workload evenly.
Precisely. Now, have you explored any specific tools for parallel job execution in our current setup? Moving on to integrating containerization tools like Docker in the pipeline can also bring significant benefits. Containers ensure consistent environments across different stages of development and deployment.
That sounds useful. How does Docker fit into our current pipeline?
Docker allows us to package applications along with their dependencies into lightweight, portable containers. This means that what works on one developer's machine will work consistently in testing and production. It's like having a standardized pot for each type of plant, ensuring they grow uniformly regardless of where they're planted.
Standardized pots would indeed make a difference.
Absolutely. Setting up Docker in your CI/CD pipeline involves creating Docker files that define the environment needed for building and running your application. Once you have those, you can use Docker Compose or Kubernetes to manage multi-container setups during testing and staging.
Managing multi-container setups sounds complex.
It can be initially, but it pays off in terms of reliability and consistency. For instance, you can use Docker images to cache intermediate build states, reducing redundant operations. It's similar to using premixed soil that already has nutrients added, so you don't need to manually add fertilizer each time.
Pre-mixed soil is definitely more convenient.
Exactly. Plus, integrating Docker with CI/CD tools like Jenkins or GitLab CI becomes straightforward with plugins and built-in support. These tools can automatically build and push new Docker images when changes are committed, streamlining the entire process.
Automating the image builds would save a lot of manual effort.
Definitely. And don't forget about versioning your Docker images. Tagging them properly helps track changes and roll back if necessary, much like keeping records of which seeds were planted where and when.
Versioning images would be very helpful for tracking changes.
Absolutely. Now, have you considered how we could start incorporating Docker into our existing pipeline steps?